Okay, 7.3, part 2. So we've already done the square of a binomial, taking a binomial times itself. That was in part 1. Part 2, we're going to look at the sum and difference pattern. What we mean by that is if I take something times itself, and the only difference is the sign in the middle. So here we have x plus 2, x minus 2. So here we're adding 2, here we're subtracting 2. Here we're adding 5, here we're subtracting 5. Adding 2, subtracting 2. What pattern do we notice? So again, we're looking for a pattern. So I'm going to multiply these guys out and see if we have a pattern here. So I'm going to distribute. X times x is x to the second. The x times the negative 2, again, negative 2, is a negative 2x. The 2 times the x is positive 2x. The 2 times the negative 2 is negative 4. These middle terms are like terms, so I can add them. Negative 2x, positive 2x. Oh, well, those just give me 0. So I'm left with x squared and then the negative 4. So I end up with x squared minus 4. Okay. The next one. Here we have x times x, x to the second. X times negative 5, which is negative 5x. 5 times x, positive 5x. 5 times negative 5 is negative 25. Again, my like terms there in the middle. Negative 5x, positive 5x is 0 again. So I'm left with x squared minus 25. Anyone notice the pattern yet? Middle terms added out, the negative 2x, positive 2x. Negative 5x, positive 5x. Let's see if it happens again. Now here we've got a 3 on the x. Let's see if it does it. 3 times 3, x. 3x times 3x is 9, x to the second. 3 times negative 2 is negative 6x. 2 times 3x is positive 6x. 2 times negative 2 is negative 4. Look what happened, the middle term, negative 6x, positive 6x. Those add again, x squared minus 4. Again, those middle terms disappeared. And these first terms, this 9x, just came from taking this 3x times itself. And the last term came from taking the positive 2 times the negative 2. This positive 2 times negative 2 got me this negative 4. So then I really don't have to worry about those middle terms. So the shortcut rule for this is if I take something plus something times something minus something, a plus b times a minus b, that's just going to multiply out into a times a plus the b times the negative b. But this negative, I can put in the middle, and we end up with a squared, a times a, minus b squared. And this here is what we call a difference, because it's a subtraction of squares. Because it's the square of a squared, b squared. Difference means subtraction. So I'm subtracting the two squares. This is what we call the difference of squares. So this pattern is difference of squares, which is super useful if you notice it. So here we've got t plus 5 times t minus 5. If I remember the pattern, all I need to do is square the t, subtract, square the 5. Da-da-da, done multiplying. Again, this only works with this pattern, meaning first term the same, second term the same. Only thing that's different is you have a plus and a minus. This doesn't work if they're both plus. It doesn't work if they're both minus. Okay, next one. I square the first. So take 3x times itself, 9x squared. Subtract, it's the different, y times y squared. Done multiplying. Okay. All right, so there's our what we call the sum and difference pattern. Or a lot of times we refer to it as a difference of squares pattern. Okay, next one. Special product patterns can be used to do some mental math. Here, if I was taking 26 times 34. Okay, one thing to notice is 26 is 4 less than 30, and 34 is 4 more than 30. So really, I'm taking 30 minus 4 times 30 plus 4, or 30 plus 4 times 30 minus 4 if we flip them over, which we can do that with multiplication. I can flip these around. So this is actually that sum and difference pattern. So I can mental math on these, meaning I can take 30 and square it, take the 4 and square it, and then subtract. Because that's our rule, right? When we have t plus 5t minus 5, I've got t plus 5t minus 5. So, but squaring 30 is not too bad. 30 times 30, well, 3 times 3 is 9. So 900 minus 4 times 4 is 16. So I'm just taking 900 minus 16. So take 900 minus 10, which is 890, and then take away another 6, which is 884. Quick way of doing a bit of mental math without having to write it all out. Okay. Just a useful way that we can use these patterns. Okay, so next I want you to do, here is the last of the your turn problems, page 375, 10 through 26 even, and 39 through 42.